Our third lecture video on angular motion will discuss angular momentum. If you remember from a previous chapter, inertia is the property of a body that causes it to remain at rest if it is at rest, or to continue with a constant velocity unless an outside force acts upon it. Rotational inertia, also called the moment of inertia, is the property of a rotating body that causes it to continue to turn in a consistent manner until an external torque causes it to change its rotational motion. The moment of inertia is determined by the mass of the rotating object and how far away that mass is from the axis of rotation. Let's compare a full cylinder to a hollow cylinder. In the hollow cylinder, the mass is further away from the axis of rotation. Assuming that both cylinders have the same mass, the hollow cylinder will have more rotational inertia because the mass is located further away from the axis of rotation as compared to the non-hollow cylinder. The further away the mass is, the more rotational inertia the object will have. The law of conservation of angular momentum reiterates the idea of moment of inertia. This law states that the angular momentum of a system remains unchanged unless an external torque acts on it. Angular momentum is represented by the letter L. I is the rotational inertia, and omega is the angular velocity. The angular momentum is equal to the rotational inertia times the angular velocity. Remember, the further the mass is from the center of rotation, the larger the rotational inertia. In the first image, the girl has her arms spread out so the mass is centered further from the axis of rotation. In order for angular momentum to be conserved when she brings her arms in closer to her body, her angular velocity must increase since her rotational inertia is decreasing. So this is why when figure skaters have their arms out, they don't spin as fast, but when they bring their arms in closer to the center of their body and their axis of rotation, they spin much faster. We aren't actually going to be doing any calculations concerning conservation of angular momentum. This concludes our discussion of angular momentum.